Looking at our 45, 45, 90 example questions, let's get right into this. We're going to be using that idea of either multiplying by root 2 if we have the leg or dividing by root 2 uh, if we have the hypotenuse. We also have another option if we have the hypotenuse. So first off, we have the leg. We're trying to solve for C, which is our hypotenuse. So if I have the leg, I'm going to multiply it by root 2. So all I'm going to do is take my 7 times root 2, and that's going to end up being my answer. That's it. That's all I need to do. If I really want to plug it in and get a rounded answer, 9.899 would be acceptable. It is going to repeat. It is going to go on in a much larger number. Um, So 7 root 2 might not be the pretty looking answer. However, it is going to be the most precise answer, so it is the answer that we prefer most often. Down here, we have an option for our hypotenuse. This is going to be a situation where we're going to want to divide by root 2 because we have a root 2. Okay. If we had a whole number, we'd use that multiply by root 2 over 2. However, in this case, we don't. So all we're going to do is to find a, we're going to take 12 root 2 over root 2. And if you pay attention, those root 2's are going to cancel out. So a is going to equal just 12. Okay, that's all we need. It's just going to be 12. So that simplifies things quite a bit for us in terms of solving for our hypotenuse. Now let's get into some that are going to challenge us a little bit more. In this situation, we've got a leg. Okay, so in order to find the hypotenuse, I'm going to multiply by that by root 2. B is easy to find. It's just going to be 2 root 2 because these are going to be the same. But in order to find my hypotenuse, I am going to multiply by root 2. So I have my a is going to be 2 root 2. I'm going to multiply by root 2, okay, because I have the leg, so I'm going to multiply by root 2. When I do that, all right, when I do that, my square root, anything underneath the square root, I evaluate together. And because I have a pair of numbers underneath my square root, they can come outside and multiply by whatever's out front. So here I would have 2 times, I have a pair of 2's, so I can pull out 1 and remove the square root because the only thing left there is 1, and the square root of 1 is going to be 1. So I'm left with 2 times 2. A is going to equal 4 in this scenario. And like we said, B is going to be 2 root 2. We already had that figured out. Down here, we're given our hypotenuse. This is going to be a situation where we don't want to divide by root 2 because we have a whole number. We're going to end up multiplying by root 2 over 2. So in order to find x and y, okay, we're going to take 4, and we're going to multiply by 2 over root 2 over 2, excuse me. So when I do that, I end up with 4 root 2 over 2, and 4 divided by 2, it can be divided by 2, it's going to just be 2. So we end up with 2 root 2 for x and y. Okay. Looking over here at this one, I have a leg, and because I have a leg, okay, I'm going to multiply by root 2. Y is going to be 3 root 2 over 2. That's going to stay the same. Nothing changes there. But for x, I am going to take that 3 root 2 over 2, and I'm going to multiply by root 2. So when I do that, I end up with 3 times root 2 times 2 all over 2. I had that pair of 2's, so they come out and multiply by 3. So I have 3 times 2 all over 2. And if I'm paying attention, this is something that I always look for. Where can I simplify? I have a 2 on top, a 2 on bottom. They can cancel out, and I'm left with just that 3. So x is just going to be 3 in this scenario. Okay, that's going to be super helpful as we go forward. Down here, Okay, I've got a leg again. 3 root 2 is my leg. It's going to equal y as well. Because I have a leg, I'm going to multiply by root 2. So x is going to equal 3 root 2 times root 2. So that's going to equal 3 root 2 times 2. Because I have a pair of 2's, I pull that pair of 2's out. 3 times 2, I can't simplify anything here. So this is going to be 6 for x. Okay. Over here, I've got my hypotenuse because it's across from 90. Okay. Because I have my hypotenuse, all right, I've got some options here. Typically, in this scenario, I wouldn't mind dividing by root 2, but looking at it right now, it might not be the easiest thing to do. So I'm going to go on ahead and multiply by root 2 over 2 in this scenario. So 2 root 6 times root 2 over 2. So when I combine that, all right, I've got 2, and then root 6 is made up of, let's take a look at that. Divided by 2 is 3, divided by 3 is 1, so it's just 2, 3, and 1. So we can say 2 times 3, and then I have that root 2 over here. That's all going to go over 2. So I can cancel those 2's out because that's all, because I have a 2 on top and a 2 on bottom. They're outside of my square root, so I can look at those separately. And then looking at the inside, I have a 2, I have a 2, and I have a 3. I'm just going to reorder those. Because I have my pair of 2's, I can pull out my pair of 2's. So this is going to equal 2 root. I still have my 3 underneath. Okay, there's a little bit more work to do with that one. However, it's not crazy difficult. We just have to take our time. This might be a situation where we're going to ask for a little bit of help in order to make sure that we understand exactly what's going on here. Down here, I've got my hypotenuse. Okay, my hypotenuse, it's a whole number, so I'm going to use the divide by root 2 scenario. 11, actually, no, excuse me. I'm going to use my multiply by root 2 over 2. So A is going to equal 11 times root 2 over 2. And I'm just going to simply put this together. 11 root 2 over 2. Can't simplify down anymore. If I wanted to plug this into my calculator, I could. 11 root 2 divided by 2 would give me, this is the answer that I'm going to prefer. Okay, but if I did plug it into my calculator, 7.778 would also be acceptable. We do have some other acceptable answers for some of these that I'll go on ahead and put in to the slides. But again, I like leaving that square root in there as much as possible. It might not be the cleaner look, but it's a heck of a lot more precise than it is if I end up rounding.